Hello friends, this is Jagdish Perk Associate. Today's topic is thermodynamics. So in thermodynamics, I'll be explaining a solved problem from the chapter Work and Heat. So before going to this video, please press the subscribe button of our channel, the Mechanical Engineers Team, and also click the bell icon so that you will get the notifications for new videos. So let's begin. First, I will read the question. A linear spring has a constant of 100 Newton per meter. How much work is needed to stretch it from a free length of 1.5 meter to a final length of 2 meter? Now I will analyze the question. A linear spring is there, and the spring constant for this linear spring is 100 Newton per meter. First of all, what is this spring constant? Spring constant represents the stiffness of the spring. So here, the stiffness of the linear spring is 100 Newton per meter. To be precise, this 100 Newton is the restoring force and meter is the displacement. For every 1 meter, the linear spring has a restoring force of 100 Newton. Okay? Now, the linear spring is being stretched. So the length of the spring increases from 1.5 meter to 2 meter. So in this question, we have to find the work done for stretching the linear spring from 1.5 meter to 2 meter. Now I will list out the given conditions from the question. First one is spring constant, which is 100 Newton per meter, and it is represented as K. Next is initial length of the spring, which is 1.5 meter, and it is represented as X1. Third is final length of the spring, which is 2 meter, and it is represented as X2. So by using these three conditions, we are going to find the work done in stretching the linear spring from 1.5 meter to 2 meter. Now I will move to the solving technique. First I will find the distance stretched by the spring or stretched length, which is represented by X. So the formula for stretched length of the linear spring is final length of the spring minus initial length of the spring, which is X is equal to X2 minus X1. X2 is 2 meter, X1 is 1.5 meter. So X is equal to 2 meter minus 1.5 meter. So 2 meter minus 1.5 meter is 0.5 meter. So X is 0.5 meter. And consider this one as equation 1. So X is equal to 0.5 meter is distance stretched by the spring or stretched length of linear spring. Now we will find the value of work done in stretching the linear spring from 1.5 meter to 2. And the universal formula for work done in stretching the spring is given by W is equal to minus of Kx square. And consider this one as equation 2. In equation 2, we know the value of K, which is spring constant, and we know the value of X, which is from equation 1. Okay, just substitute the values in work done formula. We get W is equal to minus of into 100 Newton per meter into 0.5 meter whole square. So here minus half into 100 Newton per meter is minus 50 Newton per meter, and 0.5 meter whole square is 0.25 meter square. So in this RHS, I'm going to split the numerical terms and S units. So W is equal to minus of 50 into 0.25 into Newton per meter into meter square. Here 50 into 0.25 is 12.5, and Newton per meter into meter square is Newton meter, because meter and meter square gets cancelled. So remaining will be meter. Okay. So W is equal to minus 12.5 Newton meter. Here Newton meter is joule. So W is equal to minus 12.5 joule. So work done in stretching the linear spring from 1.5 meter to 2 meter is 12.5 minus 12.5 joule. So this brings an end to the explanation of this problem. I hope you all would have understood. If any doubts are there, please do comment in comment box. And remember to like, share and comment on our videos. Thank you friends.